Ionic bond. In the electrostatic force between oppositely charged ions, the ions are formed from atoms from the transfer of one or more electrons. Covalent bond. Bond formed between two or more atoms by sharing electrons. Metallic bond. Bonding in which the bonding electrons are relatively free to move throughout the three-dimensional structure, responsible for high electrical conductivity and luster. Octet rule. Atoms tend to gain, lose, or share electrons until they are surrounded by 8 valence electrons. Lattice energy. The energy required to completely separate a mole of a solid ionic compound into its gaseous ions. E equals kD. Lattice energy calculations. This is used for ionic compounds if the charge is the same. D usually makes the difference. Nonpolar covalent bond. A covalent bond in which the electrons are equally shared. Polar covalent bond. A covalent bond in which the electrons are not shared equally. Electronegativity. The ability of an atom in a molecule to attract electrons to itself, ionization energy, and electron affinity or properties of individual atoms. However, the two are related. An atom with a highly negative electron affinity and high ionization energy will attract electrons from other atoms and resist having its electrons taken away. It will be highly electronegative. Polar molecule. A molecule that possesses a non-zero dipole moment. Dipole. A molecule with one end having a slight negative charge and the other end having a slight positive charge, a polar molecule. Formal charge. Valence E minus unshared E minus hash of bonds. Bond enthalpy. The enthalpy change, delta H, required to break a particular bond when the substance was in the gas phase. Bond enthalpy is always a positive quantity because energy is required to break chemical bonds. Bond order. The number of bonds, aka single bond equals 1, double bond equals 2, etc. HF. Of the hydrogen halides, which is the only work acid. HV. E equals lambda V. C equals Hc lambda E equals percent to mass to moles, divide by small, multiply till whole. How do you get the empirical formula given percent? Actual, theoretical x 100% yield equals clon. The four elements that can hydrogen bonding. Linear 180. 2 bonds, 0 unshared. Trigonal planar 120. 3 bonds, 0 unshared. Bent 118. 3 bonds, 1 unshared. Tetrahedral 109.5. 4 bonds, 0 unshared. Trigonal Pyramidal 107. 4 bonds, 1 unshared. Bent 104.5. 4 bonds, 2 unshared. Trigonal Bipyramidal 120-90. 5 bonds, 0 unshared. Seesaw. 5 bonds, 1 unshared. T-shaped. 5 bonds, 2 unshared. Linear. 5 bonds, 3 unshared. Octahedral 90. 6 bonds, 0 unshared. Square Pyramidal. 6 bonds, 1 unshared. Square Planar. 6 bonds, 2 unshared. T-shaped. 6 bonds, 3 unshared. Linear. 6 ons, 4 unshared. SP. 2 bonding pairs. SP2. 3 bonding pairs. SP3. 4 bonding pairs. SP3D. 5 bonding pairs. SP3D2. 6 bonding pairs. VSEPR. Model that accounts for the geometric arrangements of shared and unshared electron pairs around a central atom in terms of repulsions between electron pairs. Hybridization. The mixing of different types of atomic orbitals to produce a different set of equivalent hybrid orbitals. The energy released from the formation of bonds more than offsets the energy needed to promote the electron to a higher energy orbital. Sigma bond. A covalent bond in which the electron density is concentrated along the internuclear axis. Pi bond. A covalent bond in which electron density is concentrated on opposite sides of the line that passes through both nuclei are generally weaker than sigma bonds. Energy level diagrams. A diagram that shows how the energies of molecular orbitals relative to the atomic orbitals from which they are derived. Paramagnetic. Unpaired electron exist in an energy level. Diamagnetic. All electrons are paired.